Hello, listeners. Today's episode of the InfoQ podcast is the API Showdown, recorded during QCon Plus in November. I was the moderator of the discussion, and my goal was to understand some of the high-level pros and cons of three popular technologies for implementing APIs. If, like me, you've heard about GraphQL or gRPC and wondered why you might use them instead of a RESTful API, then I think you'll really enjoy listening to this discussion. This panel is also a great example of the content you can expect from QCon, which is why I'm excited to tell you that we will be back in person with QCon London this April 4th through the 6th, and online with QCon Plus between May 10th and the 20th. These are both great opportunities to join the world's most innovative software engineers from across many domains as they share their real-world implementations of emerging trends and practices. You can learn more about both events at qconferences.com. We hope to see you there, and now enjoy the API Showdown. Hello and welcome to the API Showdown. Today I'm joined by three panelists, each chosen to be a representative of one particular API technology, more or less. Now, any good architect knows the only time you should ever use always or never is to say we will never deal in absolutes. So I don't want to paint any of the panelists into a corner as only an expert on one topic. It's just a helpful way to create a discussion with diverse opinions, because we really want to understand what are the trade-offs you need to consider when evaluating your options. Now that I've said I'm not going to paint them into a corner, I'm going to tell you which panelist is in which corner. So representing gRPC, we have Alex Borisov. Alex is currently an engineer at Netflix and was previously at Google, who gave us the G in gRPC. Hello, Alex. Next, Michelle Garrett is part of the team building Twitter's large-scale GraphQL API. Twitter picked her up after she did an amazing job implementing GraphQL at Condé Nast, where surprisingly, they did not put the GQ in GraphQL. Hello, Michelle. And I hope they're both ready to meet Matt McLarty, who's certainly not resting in the third corner. Matt is a global field CTO from MuleSoft, co-author of two O'Reilly books on microservice APIs and architecture. And when he's not behind a microphone here at QCon, he's behind a microphone as co-host of the APIs Unplugged podcast. Welcome, Matt. So I want to start off with brief origin stories. Now, APIs have existed for as long as we've needed two systems to be able to talk to each other. But for various reasons, this has led to the invention of countless protocols, patterns, and paradigms for developing APIs. And we're now at a point where with any of the three technologies you represent, someone can come in and just implement that technology right now. But at some point in the past, they did not exist. So tell me, why was your technology created? We don't need a whole history. People can go and Google that if they want. But give me the one problem it was trying to solve and what was the innovative idea that it brought to the table. And we'll go in chronological order. So Matt, that means you're up first to tell us about REST.
Awesome. Well, and I'm only choosing REST because Corba was not an option. So there's my joke for my age category. You know, it's a great point. Like you could probably write J.R.R. Tolkien-sized books on the history of REST and APIs. And yes, Roy Fielding had the dissertation, which kind of defined the style of representational state transfer, which really was kind of like showing in a thesis, hey, here's how you can define an architectural style and let's choose how the web works. So we'll use REST. You know, in terms of solving the problem, I think what's really interesting is it was a very organic adoption of REST in a lot of different uses, right? Like at the time, there was a lot of energy behind SOAP in the enterprises. You know, here's a way of using web technologies to connect things and all these very prescriptive standards about how to write SOAP messages. So REST's rise was really sort of in response to, in rebellion against this SOAP, and started just being like, hey, here's a practical way of doing things. What if we just use HTTP verbs and define things as resources over the web? So if I had to generalize what problem it was meant to solve, you know, it's kind of like the web itself. Like if we go underneath the browser on webs, how do we just plug things together using web protocols? And that's why I think part of the power of REST and part of the ubiquity of REST has been its wide adoption in many different use cases. And I think people learning it in one area and then applying it in another. And you can even argue that it used to be you just connect to the eBay API or something using REST in the early days. Then it was like, well, what if we use a REST API to do deployments or do some sort of management over web networks? Then it was, oh, there's these mobile devices. How are we going to expose systems to mobile? Oh, well, we can use this REST thing that seems to be working in other places. So it really has been a very organic thing, which can be probably, you know, some of the reasons that new protocols have emerged has probably been based on its ubiquity and the compromises that come with that and the ambiguity that comes with that. But the story of REST is really the story of the web.
So next, chronologically, according to my research on Wikipedia, is GraphQL. So Michelle, why do we have GraphQL? What does it give us?
Yes, thank you for keeping my GQ GraphQL joke alive, by the way. Okay, so GraphQL was originally developed by Facebook in 2012, and then the spec was first released publicly in 2015. So it's been around open source for about 6 years now. And the history of GraphQL at Facebook is quite widely written about, and you can look up online and find out all about it. But I'll give you a brief TLDR. Ultimately, the first ever implementation of GraphQL was the Facebook mobile newsfeed API. And the problem that Facebook engineers were trying to solve with GraphQL was that pain point of having to make loads of different API requests back and forth from different endpoints in order to get all of the data that was necessary to render a view, which in this case is the very complicated Facebook newsfeed where everything is interconnected and nested with each other. And this was coupled with the problem at the time of people shifting to mobile and using really bad 3G mobile networks. So GraphQL was invented to solve those problems at Facebook. And the fresh idea that GraphQL brought to the table was really thinking about data in terms of a graph instead of multiple endpoints. So unlike REST APIs, which expose data via multiple different endpoints, GraphQL exposes all of the data through a single endpoint that is flexible. And when you build a GraphQL API, you're really trying to build a unified data graph, which client developers can then query a subset of based on what their needs are. And so really the key feature of GraphQL and what everyone loves about it and what is innovative about it is that it empowers client developers to select exactly the data that they want from the API and get back exactly what they've asked for without anything else. And they get it all in one go. So that's GraphQL.
All right, Alex, that means you get to tell us about the newest kid to the party, gRPC.
Absolutely. Hello, everyone. Thank you, Thomas. And by the way, contrary to popular belief, G doesn't stand for Google. I'll send you a link for what G stands for. But Thomas mentioned that gRPC was the newest kid, but in fact, it has older siblings at Google. And gRPC is just a new version of Stubby, the API technology Google used internally for a long time, for over a decade. This new version is based on HTTP2, and it accumulated all the knowledge and lessons learned during those long years of running truly distributed systems inside Google, something that we call microservices now. In a way, gRPC was a set of best practices for efficient remote communication implemented in a one open source RPC framework. And gRPC was released shortly after HTTP2 specification was published. One of the ideas was to bring all those performance improvements and capabilities of HTTP2 into a simple, performant, easy-to-use API-first framework that can be utilized in a number of scenarios, from high-throughput backends to communication with devices on unstable mobile networks with limited CPU and memory footprint. So the idea was not to create an architectural style. The idea was not to create a query language. The idea was to offer a collection of technologies that help you as a developer build and run distributed system with large number of remote calls and hide all the HTTP2 protocol implementation detail. Give you as a developer a framework with efficient wire format, fast serialization, deserialization, and built-in features you will need to run your system, and help you focus on modeling your business-oriented actions as opposed to HTTP protocol details.
The next question I want to ask, most of the attendees here probably are architects or fulfill the architect role sometimes in their job. And you always have to look at these trade-offs and wonder, well, what's the right tool for the job right now? And I'm not saying that one tool is always correct, but can you give us one example when I see a problem and my tool is the right solution in that situation? And just out of courtesy, we're going to go backwards in this. So Alex, you can go first and tell us, what problem do you see that gRPC is like, that's the right tool for the job?
Well, if you're designing a low latency, highly scalable distributed system, you should at least consider using gRPC. The default out-of-the-box implementation is using protocol buffers as an IDL and serialization mechanism. And by the way, I said by default because, again, gRPC is actually encoding agnostic. Technically, you can use gRPC without protobuf, but for the sake of time, let's stick with protobuf. Protobuf is wire efficient. You're not sending giant string payloads. You're not spending resources on parsing those strings. In some languages, string parsing can be extremely inefficient. And if your backend is used by mobile clients, they will be more tolerant to bad network connections because you just send less data over the wire. And those clients will need to spend less CPU on deserialization, which helps with battery life. On the other hand, if you're building a backend system that include or at some point will include hundreds or thousands interconnected microservices, gRPC will offer efficiency and speed, and also will provide built-in features like deadline propagation, cascading cancellations, retries, request hedging, and so on. We can discuss any of those techniques in depth if you want later. Or perhaps at some point, you will need streaming APIs. Your application needs to stream multiple requests or multiple responses in one RPC interaction. Maybe your application streams data from sensors or stock price, and sub-millisecond latency is very important for your business. You may need flow control or back pressure for the streaming APIs. So streaming RPCs with flow control have first-class support in gRPC. And you will probably need TLS. At some point, you will need load balancing, custom authorization, monitoring. gRPC provides building blocks with default implementations and extension points for all those concepts. And the best thing is you don't have to think about all those features until you need them. gRPC is very easy to start with. You can give it a try just for expressive language-neutral IDL and auto-generated client libraries, and later start using those additional features and extensions when you need them. Did I cover enough use cases?
Yeah, that was a little bit more than one, but those were all good. Michelle, what about you? What is some place where you're like, we're starting from scratch, but we're going to go with GraphQL because that's the right thing for this job?
Well, I was going to say that I want to cheat and say two, but I feel like I can do it now.
Oh, yeah.
I'll make it quick. I have two use cases and I can't choose between them because they're both great. The first one is where you have one client application with many data sources. And the second use case is when you have many client applications and one shared data source. So let's talk about the use case where you have multiple clients that need to use the same set of data in different ways. So for example, you might have a web application and a mobile application, which both need to access the same set of data, but the view looks different in both of those applications. And the interface that they need of that data is completely different. So trying to share a REST API between these two clients can result in really bloated endpoints with lots of data that is unnecessary to one or the other clients. If you use GraphQL, on the other hand, it allows both of these clients to share the same set of core data, but they can use it in a way that actually makes sense for them. And they can ask specifically for the data fields that they want, and they're not going to be burdened by the data needs of the other applications that are sharing the same data set. So that's number one. So my second beautiful use case for GraphQL is when you have multiple data sources for a single application and you want to streamline those into a single interface. So say you're building a client application and it has loads of data sources, say like 3 REST APIs, a JSON file, and a database. Maybe one of those REST APIs is a horrible legacy API that people are kind of scared to touch, and it's undocumented, and the naming is horrible, and you can't really change anything in it because it has to remain backwards compatible for other applications. So in this case, you have disparate data sources, and GraphQL is the perfect tool for the job to unite those data sources in a data layer. So you can wrap all of them in a single GraphQL layer. And this layer allows you to kind of hide the ugliness of the underlying services. You can name fields how you like. You can hide implementation details. You can relate data from the different data sources together in a way that makes sense, but you don't have to expose that they come from different services to the client. And basically, you create a nice streamlined data layer for your application.
Very nice. Matt, we're going to ignore the fact that I think Michelle just called your API ugly, but when would REST be just the right thing to do? And is it simply that that's what everybody knows and that's what we're comfortable with and that's what we use? Or is there a place where that's all we should be using?
So in this moment of being personally insulted, I'm just going to reflect for a second and invert things a little bit. Like, honestly, I think this question to me raises the question, right, of what's the right way of deciding? What criteria do you use to decide on the protocol, right? Like, I think we've heard some really good technical justifications and we've heard some design justifications factoring in consumer needs. Like, the reality is, depending on what perspective you're coming from, you could arrive at different answers. So I just wanted to pause and step out of character for a moment and say, like, you really need to think about what your consumers need first I think, especially you may be in a situation where you own both ends of the pipe, and so you've got a little more liberty to make decisions based on other criteria. But for me, step one is like, what do my consumers need? Because you might have like the perfect technical justification to go with one protocol over the others, but if your consumers really need it in one format, then that should override things. Or maybe they need multiples, but we'll get to that later. But I think the answer for REST is like everything else, or those plus everything else. I mean, again, I think that what we've seen is, first of all, how do you define REST? Because even within the community, there's lots of disagreements around that. So I agree, there's some ugly REST APIs that could use some abstraction, but it's not really dictated by the protocol. So that flexibility, again, is strength and also leads to some of the pitfalls. But I would say in general, where you meet the web, or maybe more abstractly, when you don't know who your consumers are. So when you're really aiming at an unknown audience, I think it is very beneficial to say, okay, REST is the great equalizer here, that if you don't know who's going to consume it, it's kind of the table stakes to say, have a RESTful interface. You know that there's going to be people who know how to use that, and then maybe there'll be reasons to specialize on other protocols later. But even in the examples, like we'll see some organizations will use a RESTful interface as an abstraction on top of a gRPC channel internally as a way of kind of opening up to the web. Or you'll see RESTful APIs being building blocks for a GraphQL endpoint that's aggregating things. So there's lots of combinatorial scenarios as well, but my things would be, think about what your consumers need. And if you're not totally sure of what your consumers need, then that's probably where REST is an obvious choice.
Well, let's put a pin in the idea of combining things. I'm just going to talk about that later, so preview. But I saw someone ask one of the questions that was going to be my next question is, so you've all given me a good answer of I'm the right choice for this job. We've also seen tools used incorrectly. I've seen lots of software written that, I wrote C++ style F# or something like that because that's how I knew how to write stuff. And I should have written functional, but I know how to write object-oriented. When is your tool the wrong tool for the job? Admit it, and don't tell me that we're always right and I can solve every problem, because we all know that that's not always the right fit. And the answer, of course, as Matt was pointing out, is it depends. But, give me a good, I wouldn't do it if this is what you have. You should go and choose something else. Anyone wants to go ahead, please.
I would say that there's a couple of intersections that are really getting predominant. Event-driven kind of comes around the circle every few years, right? So we're in a heavy event-driven period. And there's lots of asynchronous use cases where you can model asynchronous, like webhooks and things like that over REST, but there's places where you can certainly optimize better with a purely asynchronous protocol. But I think the big one for me is this convergence of the analytics world and big data world mashing up with the sort of user-facing application microservices world. Having lived in the distributed computing world, there's a lot of sort of assumptions made that, big data, analytics, whatever, it's just more data to handle. There's clearly a lot of cases where you're connecting things with massive amounts of data and scale of data that you don't necessarily want to put it through a straw of a more message-oriented RESTful interface. So that's probably the big one, I would say. If you're a distributed systems architect or engineer, and you're just now getting into the world of analytics and ETL of big data, like watch out for that.
So I think that GraphQL is really geared towards product engineering, and that is where it really shines, and that's where it has the most adoption. So one of the creators of GraphQL, Lee Byron, has said in the past that GraphQL really isn't the right choice for server-to-server communication. So if you're looking to build a way for your backend services to speak to each other, I don't think GraphQL is the right choice for that. Because I think the power of GraphQL is in what it gives to product developers, which is like flexibility and great tooling. And I think that the benefits are less in this kind of scenario. And you might want to look more towards Thrift or gRPC or REST, something else.
And I'll start with some obvious answers for gRPC. For example, when your language is not supported. So code generation comes with a downside that only 11 languages are supported. If your language is not on the list, you're out of luck. Or, which can be even more important, if your language is on the list, but your consumers cannot use or don't want to use a language that is supported, you should probably build your API with something else. In those cases, you can create like reverse proxies. You can use projects like gRPC Gateway that creates REST endpoints for gRPC services. Or you can use Envoy with gRPC JSON transcoder that translates RESTful requests into gRPC. But those solutions are more like workarounds. If you know that significant amount of your API consumers will not be able to use native gRPC libraries, it's probably not the best tool to use. Also, if you're building like one-off APIs that you know you will sunset soon, for example, you build migration APIs or something, the schema overhead might not be worth it. Or if you're building a service that only talks to a web browser and it doesn't call any backend services, it just calls the database. For example, it's a simple application, or you're building a monolith for a good reason. In those scenarios, you can get more benefits from another technology, GraphQL or REST. Yes, you may still be able to use gRPC, and you still will benefit from language neutral contract, from code generation. But to talk to the web browser, you will need gRPC web proxy. And communication between proxy and the web browser will still be HTTP 1.1. So if your only integration point is web browser, gRPC is probably not the best choice. And you should really understand what your complexity is. I mean, you should start with understanding what your complexity is. If your complexity is in QPS, throughput, latencies, you're concerned about optimizing tail latencies, go with gRPC. If your complexity is in complex domain that you have rich UI application, pulls data from dozens of services, GraphQL can be a better choice.
So, Alex, you kind of mentioned the idea of code generation being critical for gRPC. And my next question was about what does it take to get started? Like, if I'm just exploring this, I may know some things about REST and I may know how to like just make an HTTP request, because you just have to make an HTTP request. And that's very easy to learn. If we assume that all this is client server communications, even if it's server to server, one of those is a client, one's a server. What does it take from the server side and what does it take from the client side to say, I now have two components of my system that can talk to each other? And since I already mentioned Alex and CodeGen, why don't you go first?
Yeah, absolutely. I mean, first, your consumer and producer, client and server, they have to agree on the protocol. gRPC is an API-first framework, so an API contract is not an afterthought. It's the very first thing you start with. Again, for simplicity, let's pretend it's only protobuf. And unlike REST or GraphQL, in gRPC, you model actions, you model your methods, you define your service, which is just a collection of actions that your server can do. And your server can be resource-oriented, but it doesn't have to be. You define what it can do, and this action can be defined around data entities or can be not. And then, even though gRPC is based on HTTP protocol, gRPC does not expose any HTTP details. So this protobuf schema is very simple. You define your request as a proto message, your response as a proto message, and your method. And then you will need to use protocol buffer compiler with gRPC plugin to generate classes for both consumer and producers. For example, let's say we define the QCon service with two actions, attend the session and attend lunch, two most important things you can do during the conference. So attend session takes request, returns a response. So your API definitions will be compiled into classes in a language of your choice. For example, let's say we use protocompiler with gRPC Java plugin. For backend, it generates an abstract class called QCon service impl base. And backend developer would need to extend this class, override the attend session, override attend lunch methods. So no annotations, no mapping. You just need to implement methods in your language. And for the client, protocompiler generates client stubs and client libraries with methods attend session and attend lunch. And in fact, it generates two types, two subsets of client libraries, synchronous and asynchronous. In Java, it will generate three clients: blocking client, callback-based client, and future-based client. So gRPC encourages you to use non-blocking clients, but you can start with simple blocking client and then switch to asynchronous later on if you need to. And you can just start with instantiating those generated clients, and you use your data entities, you build a request, and then call this method to invoke a server. And all the heavy lifting, serialization, deserialization, opening streams, managing connections, working with HTTP2 frames, it's all hidden. gRPC doesn't expose any of those details. So the framework has already made all the decision on how to layer your RPC model on top of the protocol.
Now, Michelle, what is GraphQL? Again, I've seen little tutorials of here's how to get started with GraphQL. And it seems like there is that, like, how complicated is it really? Do I need a new server? Do I just write some code and deploy it out?
Yeah, so with GraphQL, everything starts with a query or a mutation. So If we're talking in CRUD terms, a GraphQL query is equivalent to reading data, and a mutation is when you want to create, update, or delete some data. And let's go with queries because it's the most straightforward one. So a GraphQL query is essentially like a shopping list of all the data that you want to get back from the GraphQL API. So you write down a list of all the fields that you need, and you can pass any important arguments like a user ID. And all the fields that you write down, they have to correspond to the GraphQL schema, which is a strictly typed contract that describes all of the data that it is possible for you to ask for from the GraphQL API. And GraphQL APIs have just a single endpoint, usually /GraphQL, usually a post endpoint. And when you want to make the request, you post your GraphQL query to the endpoint, and the server will receive your query. And then on the server side, there's things called resolvers. You define a resolver for every single field in the GraphQL schema. And it's essentially a function that tells GraphQL how to populate that data. And you can pull that data from anywhere you like. You can pull it from other REST APIs or a database, or you can just return a string, whatever you want to do. But basically, the server will read through the query, look at all of the fields, and populate those fields with data one by one based on the resolver functions. And then once it's done that, it'll return it to the client.
Matt?
I want to, once again, get out of character a little bit, because there's an element of design that happens independent of the protocol. Like, I think that's an important point to make. Like, the first thing you should worry about isn't like, let me run and start writing my protobuf definition or my GraphQL schema or my JSON schema, right? I think there's an element of design of just, again, like I said before, thinking through who your consumers are, thinking about what are the actual, whether it's resources or schemas or, messages, what's the actual like business activity that's going to take place on the interaction. And that's so important, because I think if we look at REST and, if we want to just use like the basic definition of CRUD over HTTP using resources, I think everyone probably knows, everyone's familiar. There's a bazillion implementations of clients and servers there. And it's great, the developments that have been made in Swagger and OpenAPI specification to help drive more metadata. And there's flexibility to plug in JSON schema and security schemes. Like, there's all that technological goodness that I'm sure Kin undoubtedly did a phenomenal job of explaining a lot of the details around that. But I think to get started with REST, if you're thinking in a bigger context of, oh, I'm actually creating an API that's going to be a new channel for my company or for my business. Like, we talk about this idea of APIs as products a lot. I've got the book here on continuous API management from my friends that wrote it. There's this whole aspect of thinking through, like, how are people going to find my API? How will it be discovered, right? What is the different segments of consumers involved there, right? How am I going to handle versioning and all that? So I think the reason I bring it up now is because I think there's a temptation to just say, let me get the MVP quick start thing out there. But I think the sooner you start to think through, okay, let's just put the technology aside for a second and think of all these product considerations, it's really fundamental to do that, because what's that Mary Poppins quote, right? The biggest failure in technology is not having something crash, right? It's building the wrong thing. So, the more thinking you put into what is it, tuning what you're designing for, I think that's key. And that to me is a big part of getting started.
I think that's a great callback to the people who saw Christy Schneider's presentation talking about designing for extensibility. She talked a lot of the same things without specifically mentioning it was just APIs. It really is, if you have this product that you're trying to adapt over time, how do you version it? How do you document? How do you teach people about it? How do you get them to adopt it?
On the theme of architecture, right? Like, I think architecture, what's the difference between architecture and design, right? Could be just architecture, those decisions you make that have long-lasting implications. There are things you can do up front that will snooker you on preventing, creating landmines down the road. So it's definitely important to put that thought in.
I did want to ask at least one narrow technical question, since it is an architecture track. One of the themes we science here about is CQRS, command, query, responsibility, segregation. And I want to know, how does that get implemented in each of these things? I think, Matt, it's pretty obvious. You write a command, you write a query, or you have different endpoints for those things. But is that no longer RESTful? And do we care?
Well, again, CQRS has kind of grown out of domain-driven design. I think it was like there's this whole evolution of CQRS. I've heard people sort of sarcastically say CQRS was just a thing Microsoft was pushing because they couldn't get SQL Server to run effectively without separating commands and queries. But I think notionally, it's been actually a pattern that's been in place for a long time. So you could absolutely separate your gets. If you want to have a proxy that does filtering and dynamic routing and then goes back and hits different backends, at what point do you want to make the separation happen? right? Is it right at the network layer? Do you want some application layer? Do you want to have some data separation? So typically, I would say working in the enterprise space that I usually am working with customers in, there's a lot of different optimizations that happen on the chain. And I'm not seeing a ton of organizations being purists around CQRS. Those that are tend to be more in the going all in on event modeling and sort of event sourcing approach where they're optimizing specifically for that type of separation. But it's doable, but I think the main point is that there's lots of different points in the stack where you might want to have separation for optimization purposes.
Now, Michelle, there's a Q in GraphQL, but there's no C. So do commands not even work through GraphQL, or is that something somebody else should be responsible for?
I've honestly not heard this acronym before, so maybe you can tell me.
It's the idea of separating. You have a path where you go down and you write all of your queries against a read model, if you will. It's like writing like Matt said, SQL Server was being slow, so you wrote materialized views so they would read faster, or whatever you did, but that you don't write a document and read a document the same way. So GraphQL seems to be, I'm going to aggregate all my data together and I can ask all these different questions. Just give me this little bit of data. But it's not meant for, please send a message to the next person in the queue or something like that.
Yeah, that sounds reasonable to me.
Just to add something on GraphQL, I just want to pick up on it. That's okay. I think it's interesting that you've got queries, mutations, and subscriptions, I think, as well, right? And I've been banging this drum around commands, queries, events, whatever you want to call them. Like there's these three different interaction patterns. Again, that goes back to the fact that maybe these protocols aren't all that different. We're solving similar problems, and there's a unified conceptual view of the world that is expressed in all three. I'll hand it over to Alex now to give his.
I'll give Alex just a brief answer, and I'm already going to set you up because I know RPC is remote procedure call. It doesn't imply what you're doing. You can do whatever you want, right?
Absolutely. It does not. Yes, you can easily define separate services. You can define service to read your data, and it's separate service to mutate your data. So you will have query service and command service. They can be implemented by the same gRPC service, but services are just namespaces, if you will. So if your consumer is a reader, they use your query service. If they're a writer, they send commands using your command service.
So we've got about 3 minutes left. And last question, I already teed it up. So you started off by saying, I'm the one technology to win them all. But if you had to choose somebody else, and you're going to say a two sizes fits pretty well option, which of the other choices in the room would you pick? And since I started this with chronological order, we'll go in reverse, even if Alex said I was wrong about the timing. So Alex, go ahead. If you're not the right fit, who do you want with you?
If I have a rich UI that aggregates data from multiple sources, I'll go with GraphQL. I may end up supporting two ADLs, but that's the price I pay. On the other hand, if I have a subset of consumers who can't or don't want to use gRPC clients, I'll go with REST.
Give me the it depends on the please pick one and you choose us both.
Different scenarios. That's why.
Exactly. Michelle, if I said we couldn't just use GraphQL everywhere, who's your wingman?
I'm going to pick REST as my wing woman. Although, I feel like REST and GraphQL are pitted against each other. And I'm sorry that I called it ugly earlier on. I think that they have a lot of harmony together, and they're often found together in real world implementations of GraphQL. There are just so many REST APIs in the world, and I don't think REST APIs are going to go away. And I think that wrapping a REST API in a GraphQL layer, but maintaining the underlying REST API services is a really common pattern and is like a sweet spot for the two of them to work together.
Matt, it's up to you. Who's winning this? Who do you pick?
One of the reasons I'm here is that, and thank you, Michelle. One of the reasons I'm here, the article I wrote, which is specifically calling out these false dichotomies. I can't sit up here with a straight face and say, oh, I will pick one or the other, right? Because it is silly to have gRPC is better than REST and REST is better than GraphQL. Like the whole point is, and in that article, I was stressing this kind of ubiquity and the value of that, but then the trade-offs. So I'm going to go with Kafka.
Wow, didn't see that coming.
We know it depends.
Thought it might have been Corba once again coming back up. This was a lot of fun. I have 700 more questions we couldn't get to, and I hope everyone has a good day.